So today we are going to be looking at lesson 3-3, day 1. We're going to be adding and subtracting radicals and multiplying radicals. So the first thing we're going to look at are the steps involved when adding and subtracting radicals. So for instance, you're going to first simplify all radicals. So when we add or subtract in these problems here, each of these radicals here, each of these need to be fully simplified before you try to add or subtract them. Then you're going to identify the radicals that have the same index. So if you recall from yesterday's lesson, the index is this number right here, and this is your radical. So we can only add and subtract radicals that have the same indexes. It's almost like terms. So remember, if the index is missing, that means it's a square root or the index is 2. So down here, these two have the same index, both 4, but this one has an index of 3. So only these two can be combined as long as what's underneath the radical is identical. So right now, this is 48 and this is 3. So even though they're the same index, I cannot subtract these radicals. It's almost like adding and subtracting like terms. You have to have the same radicand, the number under the radical, and the same index. And then all you do is add or subtract the coefficients that are in front of the radical. What's inside the radicand will not change when we add and subtract. Just like when you add and subtract like terms, the variable string itself doesn't change. You only add and subtract the coefficients. And so that's what this is saying here. For common radicals, which are the same index and same radicand, the number underneath the radical, you just add and subtract the coefficients, that number in front, and then you keep that common radical. It doesn't change. So here we go. I'm going to actually blow this up even more so it's easier for y'all to see. Straighten that out a bit. There we go. Okay, so for right now, I have 2 square roots, but this is 27, this is 12, and both of these can be simplified further. So for the first thing I'm going to do is prime factor these. So remember, this is 3 and 9 and 3 and 3. So I can rewrite the first radical so that it is 3 square root of, I'm going to go ahead and stretch them out, and then minus, and then the 12 is 3, which is prime, and 4, and then 2 and 2. So as we get further along, I'm going to not go through all the factor trees. You can do them if you don't know what they are, but I'm going to circumvent that a little bit. Okay, so then remember from yesterday's lesson that you're going to, since our index is 2, we're going to look for groups of 2, and only one from that group comes out in front and gets multiplied to what's in front. Whatever's left over stays underneath. So this becomes 3 times 3 is 9, square root, and then we have that 3 left over. So again, I did 3 times 3 is where that 9 came from, and so then this goes away, and then this 3 goes underneath. And then minus, and then I can circle this pair of 2's, so it comes out in front, and one of the 2's gets multiplied to that 2. So 2 times 2 is 4, and then this 3 is left over, so I have radical 3. So now both my index, both 2, and my radicand are 3. So these are like radicals. So all I have to do is take the 9 and subtract the 4 and then tack on that radical. So I have 9 radical 3's and I'm subtracting 4 radical 3's. So how many radical 3's do I have all together? I have 5 radical 3's. And this is my final answer for that one. So then let's move this over, and you try this one on your own. So pause the video and try this and then restart it. All right, so for 54, that would be 9 times 6, which would give me a 3, and then a 3 and a 2. So then I'm going to have 3 cube root of, stretch this out, and then minus 2 cube root, and I guess I can change that blue, so I'll put that 2 in front, cube root of 2, and then minus or plus 7, and then cube root of. Now, remember from yesterday that we want to split out that negative, so it becomes a -1 and then a positive 16. And then, so this is one of our pieces, and then the 16 is going to give us 2 to the 4th. If you don't believe me, do your factor trees. So then I have -1, and then times 2 times 2 times 2 times 2. Now, if you think about it, I could have, so -1 is interesting. Remember, I can take the cube root of -1. I can actually change -1 into -1 times -1 times -1. So I can have as many negatives here as I need to, so long as I have an odd number of negatives, because an odd number of negatives is going to multiply to still give me -1. And because my index here is 3, I need a group of 3. So I am going to basically take out this group of -1s, and I'm going to bring it out in front. So it's going to get multiplied to that 7. And then I also have this group. Let's see if I can choose. I don't have a lot of colors here. Oh yeah, I do. All right, hang on. I'm going to get me another color. All right, so then I'm going to take just this group of 2's here and pull that out in front and multiply to the 2. And then this 2 is going to get left over. And then over here on this one, I can pull out this group of 3's out in front and multiply to that 3, and then that 2's left over. So right now what I have is 3 times 3 is 9, cube root, and then I have 2 left over. Then minus, nothing happened to the 2 cube root of 2. I couldn't simplify that. And then plus 7, so here I have a 7 times a -1, which is -7, times a 2, which is -14. So actually, instead of a plus, I'm going to change that to a minus, because it's -14. And then cube root of, and then we have a 2 left over. So now with this one, they're all cube roots, and they're all the radicands are 2. So all I have to do is look at the coefficient 9 minus 2 and minus 14. So 9 minus 2 is 7, and 7 minus 14 is a -7. So I have -7, and then the index and radicand stay the same. And so this becomes your answer for number 2. All right, let's look at number 3. So number 3 has some different radicands here and here. So these two are the same, this one's different. None of them have the same radicand, or I'm sorry, these are different indexes. None of them have the same radicand. But let's go ahead and simplify everything, because you don't know until you simplify. So 4 times 12, and then the 4 is 2 squared, and then the 12 is 2 squared times 3. If you don't believe me, do your factor tree. This one cannot be reduced. 72 is 9 times 8, and then 9 becomes 3 squared, and then 8 becomes 2 to the 3rd. If you don't believe me, do your factor trees. So then I end up with, and so I want to try to get you to quit stretching things out. So we're going to explore something a little different this time with this problem. So I have a 7 in front, and I'm going to write my prime factors in exponential notation. So remember, when multiplying like bases, the 2's are like bases, you add the exponents. So 2 plus 2 is 4. So I would have 2 to the 4th times 3 to the 1st. Then minus 2 4th root of 3, and then plus 3 cube root of, and then I have 3 to the 2nd times 2 to the 3rd. Okay, so then what I would like to do is start thinking about something that you learned yesterday. So if I have things in power format, and power format means I have a base raised to a power, I can take this index right here and divide it to each of these powers. If it divides into this exponent up here at least one time, then I can take out one of these bases for every time that this index goes into here. So if you think about it, I'm looking for groups of 4. Don't I have one group of 4 2's here because it's 2 to the 4th? And here's how it works. So I'm going to take this radicand right here and I'm going to divide it here and divide it here. Well, you can see that 4 doesn't go into 1 at all. So what's going to happen is we're going to end up getting here 4 divided by 4 is 1, so 2 to the 1st is going to come out. So out in front, we're going to have 2 to the 1st, which is just 2 multiplied to that 7. So 2 times 7 is 14. Don't forget to rewrite your index there. And then this is completely gone because it went in there completely evenly. There was no remainders. This one doesn't go in there at all, so then we have just a 3 left over. Then minus the next one. This cannot be simplified at all. This is a 4th root and there's only one 3, so we're just going to write it as is. So 2 4th root of 3. And then finally here, if I take this 3 and divide it into the 2, it won't go at all, not even once. But if I take this 3 and divide it into this 3, it'll go in there one whole time. So I'm going to take this 3 and divide it over here, which means 3 divided by 3 is 1, so 2 to the 1st comes out in front and gets multiplied to that 3. So plus 2 times 3 is 6, cube root of, and then 3 squared is 9. And this is gone because remember 3 divided by 3 was 1. It went in there evenly, so there's nothing remaining underneath this radical. And so now when you look at these two are the same index and the same radicand. So I can just look at their coefficients and combine those. So then 14 minus 2 is 12. 4th root of 3, so I have 12 4th roots of 3, and then plus 6 cube root of 9. So I cannot combine these two because they have different indexes. So what I want you to do is try number 4. We have 2 different indexes. We have square roots here and here, and then a cube root here. Remember, with that negative, the cube root of any negative is a negative. If it were an even index, we wouldn't be able to take an even root of a negative. So this negative is just going to come out in front as a negative. So this sign will change to a negative. So go ahead and pause the video and try this one and see how you do. So then 10 radical 28 becomes 10. 28 breaks into 2 2's and a 7. Oh, 2 2's. How do I have a 4 there? Let's try that again. 2 2's. I was thinking 2 squared was 4. So you've got 4 times 7 is 28. So that's where I got that one. And then plus the cube root of, I'm going to take that negative 1 out of the 56. It'll become a negative in front of the radical in a minute. And then 56 is 7 times 8. So I've got 8 is 3 2's, so 2 to the 3rd. So 8 times 7, there's a 7. And then minus 4 square root of, and then 25 goes in here. 25 goes in there 4, 3, 7 times. So 25 times 7, so 25 is 5 squared. And then times 7. So again, you can do your own factor trees if you don't believe me. All right, so then I'm going to take the fact that this is a square root, and I can divide this power by 2 evenly. So that means that out of here is going to come a 2 out in front, because 2 divided by 2 is 1. So for the first one, I get 20 square root of, and then you have that 7 left over underneath. And then for the next one, right here, this -1, this is going to come out as a negative, because a cube root of -1 is -1. So I'm going to put a minus here. And then I can take this index of 3 and divide it here. So that's what I'm going to do. I'm going to take and divide this by 3. The 7 isn't in power form, so I can't do that. So then this one is going to come out here as just a 2, right? So because I'm multiplying the 2 to a negative, it becomes a -2 cube root, and then we have a 7 left over. Now I will not be able to combine these. They have the same radicand but different indexes, so they are not like radicals. All right, finally, I am going to take this as a square root here, so I'm going to divide this one by 2. I can't divide the 7, and so that means that this is going to come out in front as just a 5, because you just take one of them. Whoops. And then I get minus 5 times 4 is 20. It's a square root of 7. So then my like radicals are the square roots of 7s right here and here. And so notice that I have a positive 20 and a negative 20. So the positive 20 and the negative 20 are going to cancel with each other. They're opposite signs. And then this is going to end up being my answer right there. So my answer is -2 cube root of 7. Final answer. All right, let's see what we have next. So this time we have some variables in here. So we have some variables underneath the radical, and we have some variables out in front. So we're hoping to simplify this to just a 2 underneath, and notice that the indexes are 2. So I'm going to take the 98 and I'm going to prime factor it. I know that 2 at least goes into 98, so let's just start with 2. So 2 is prime. And 2 goes into 9 4 times, and into 18 9 times. So this becomes 7 and 7. Okay, so then that means that if I have a square root, I'm going to take out this pair of 7s out in front. So I'm going to have a 7 out in front. And then I can take this index right here and divide it into both of these, and it will divide in evenly. So 4 divided by 2 is 2, so I'm going to get an x squared out in front. And then 2 divided by 2 is 1, so I get a y to the first out in front. And all I have left over is this 2 right here, because these divided evenly, so they're gone. All that's left, and then this has been circled, it's gone, all that's left is this 2. And so remember, I said I was hoping to get a square root of 2, which I did. And then this one right here is fully simplified, right? There's nothing I can take out there. So I have a -3 x squared y square root of 2. Now they both have the same index of 2 and the same radicand of 2, so they're like radicals. So then all I have to do is look at the coefficient in front. Now because the coefficients have variables, they have to have the same variable string. Notice that this has x's and y's and this has x's and y's. But that's not enough. They have to have the same variables raised to the same power. So this is x squared y, x squared y, so they're alike. So all I have to do is do 7 minus 3, and that gives me All right, so as you simplify 40, the negative is going to be pulled out. So I have a cube root of -1 times, and then 40 is 8 times 5, so 8 is 2 to the third times 5, and then a to the 7th, plus 2a squared times the cube root of 135. Let me do that over here to the side. So 135. I know that 5 goes in there. So 5 goes in there twice, and 7. And so 27 is 3 to the third. So 135 is going to be 3 to the third times 5 times a to the fourth. Okay, so this one's a little bit more difficult than the one we just did, and I'll show you why here in a minute. So the -1 can be brought out as a -1. So the cube root of -1 is always -1. Any odd root of -1 is going to be negative. And then we can take the index here and divide it into this, which is going to give us a 2 to the first, and it goes in there evenly. 5 is to the first, so I can't divide that. So that one's going to be left over. It's going to remain underneath the radical. But the a to the 7th is going to be interesting, because if I take that index of 3 and divide it in here, I want you to do your division out here to the side. So if I take 7 and do long division by 3, 3 goes into 7 twice. 3 times 2 is 6. So that leaves 1 remaining, so a remainder of 1. So that means that 2, right here, 2 a's are going to come out in front. So a squared, because 3 went in there twice, so a squared comes out in front, and 1 is going to remain underneath. So here's what it looks like. So we have a -1 times 2, so that's a -2, and then the a squared is going to come with it, so a squared, and then underneath the radical, don't forget your index, you're going to be left with that 5 and then a single a. Okay, and then here, let's look at this one. So we have a 2a squared out in front, and then let's see what we can do. So we have this index here of 3, so let's divide it in here evenly, so it goes in there evenly. We're not going to divide 5 to the first by anything, because 1 cannot be divided by 3, but then this is a 4. It kind of looks like a 9, but it's actually a 4, and so I'm also going to divide this by 4. We'll talk about that one in a minute. So this one, let's start with what we have out in front. So this one right here, this one's going to come out in front and get multiplied by the 2 as a 3, because 3 divided by 3 is 1, so 1 3 comes out in front, and it has to get multiplied to whatever's in front. Remember, your 5 is going to stay underneath, okay? And then we can actually divide this 3 into the, oh, I put a 4 there. Why didn't y'all say something? See if I can erase it. Sometimes it lets me, oh yay. All right, so then this 4 is actually divided by 3, right? Because that's your index. So 4 divided by 3, let's do that off to the side. So 4 divided by 3. 3 goes into 4 once. 3 times 1 is 3. And then remainder 1. So I know that 1a is going to come out in front. So from here, 1a is going to come out in front and get multiplied to that. So I'm going to just multiply it this way. So times a, that's an a. And so what happens is we get 3 times 2 is 6. A squared times a to the first, when multiplying like bases, you add their exponents, so I get a cubed. And then that's the cube root of, and all that's left is a 5 and an a. Okay, so this one's kind of weird, because this is one coefficient and this is the other. Are they like terms? No, because this is a squared and that one's a cubed, unfortunately. So what we're going to do is we're going to take this and this, because we have the same index and the same radicand. I'm just going to take those two and I'm going to write them as negative 2a squared plus 6a cubed. You could have also written it as 6a cubed minus 2a squared. I'm going to put that in parentheses in front of the cube root of 5a. And then that's odd, but that is our answer. Okay? So that's probably a toughie. All right, so let's move on to multiplying. So when you're multiplying, so I'm going to zoom out here a little bit. When you're multiplying, that's a little crooked. Here are your rules right here. So you're going to multiply coefficients and then use the product rule. So, for instance, to multiply two indexes or two radicals, you have to have the same index. So you're going to, basically, if these indexes are the same, you can just combine them as one radical. So, for instance, this is going to be the nth root, that's an nth root, I'm trying to write it small, of a times b. We'll talk about, I better make that a little prettier. We're going to talk about when the indexes are different later. But for right now, we have the same indexes, so you can just combine them under one radical. So like for instance here, and I actually don't multiply when I combine, I still break it apart, only because I still have to simplify. For instance here, I'm not going to do 27 times 5 in case I can combine something from here to here, but 5 is a prime number. So I'm going to multiply those together, and I get the square root of, actually I'm not going to multiply them because I can still break them apart and simplify. So 27 is 3 threes, right? So 27 is 3 times 3 times 3, and then times the 5. Because my index is a square root of 2, I'm looking for groups of 2. So this 3 is going to come out in front, and you're going to have 3 times 5 left over. So you end up with 3 square root of 15. Nice, right? All right, so then on the next one, number 8, so I'm going to make these bigger now, make it a whole lot easier to see. So then on number 8, you need to multiply coefficient to coefficient, radicand to radicand. So I'm going to go ahead and break apart the radicands. So I've got a 2 and a 5, because I'm actually not going to multiply 10 times 18. That makes it harder. And then 18 is 2 times 9. Well, 9 is 3 squared. All right, but you're going to multiply the 3 times the negative 2, because that's out in front. So that's going to give you 3 times negative 2 is negative 6. And then we have the square root of, and we have all together 1, 2, 2, so I'm going to put those together. So 2 times 2. And then I have 2 3s. I'm going to go ahead and stretch those out. Sometimes it's just easier. And then a 5. So you ought to see your separate pieces. So a 2 and a 5, here's a 2 and a 5. And then a 2 and 2 3s, a 2 and 2 3s. So now, because my index is 2, I'm looking for groups of 2. So here's one group and 2 groups. So I'm going to have a 2 times a 3 come out in front and multiply to that negative 6. And then that 5 is going to be left over. So I end up with 2 times 3 is 6. 6 times negative 6 is negative 36. Square root of 5. And that's it. All right, so you try number 9, and then we'll move on to the next page. So pause the video, you try number 9, because I don't think, and we'll talk briefly about number 10, but you should be good. All right, so pause the video, try it on your own. All right, so 9 breaks into 3 squared, and then 24 is going to break into negative 1 times 8 times 3 is 24, and so 8 is 3 2s, and then a 3. So we end up with equaling 2, actually, I don't even want to do that yet. Let's backtrack just a smidge. So I want to multiply the 2 times the 5, which is out in front first. So these are going to get multiplied first. So 2 times 5 is 10. And then because the indexes are the same, I'm going to put everything underneath one index. So I have a negative 1 times, I have 3 2's. You can leave them in power form and divide if you want to. And I have 3 squared and a 3, so that's 3 3's all together. Look at me. Okay, that was supposed to be 3 2's. That's a 2 and a 2. All right, so then I have 3 3's. So now I have it all correct. I must be in a hurry today. All right, so remember that this comes out as a negative 1. So I'm going to multiply that to the 10. And then I have a group of 2's, so that gets multiplied out here. And then a group of 3's, so that gets multiplied out here. So I have 2 times 3 is 6, times negative 1 is negative 6, times 10 is negative 60. And I have the cube root of, nothing. Weren't they perfect cubes? So I'm done. Just negative 60. Final answer. All right, so then for number 10, the only thing I'm going to say about 10 is, just remember you're multiplying coefficient to coefficient. So this would be a negative 3 times a negative 1. So you'd have a positive 3 out in front. And then 64 is 6 2's, and then 3 more 2's. So you'd have 9 2's altogether. So I guess we could do it pretty quickly. So the 3 times the negative 1 is going to give you a positive 3. And then you have 4th root of, I have 6 2's here and 3 2's there. So that would give me 9 2's, so 2 to the 9th. Who wants to stretch that out? So then you can take the 4 and divide it into the 9. So if you can't do that in your head, do long division. 4 goes into 9 twice, so that means 2 2's are going to come out. 4 times 2 is 8, and then you have 1 remaining. So that means that I'm going to have 2 squared come out in front because it went in there 2 times. That's where the squared comes from right there. So 2 squared is 4 times 3 is 12, 4th root, and I have 1 remaining 2 left over. And so that was quick. All right, so this last page, we have some more monomials to multiply. And then we'll get to some binomials. So again, we're going to multiply coefficient to coefficient. Well, this has a 1 times a 5, so that gives me 5. And then underneath the radical, I'm going to stretch out what I have. A 6 is a 2 and a 3. So I guess I'll put the 3 first and then the 2. And then the 8 is 3 2's. Sometimes I'll do powers, sometimes I'll stretch them out. And then x to the 4th times x to the 5th, when multiplying like bases, you add the exponent. So we have x to the 9th. I rarely ever stretch out my variables. All right, so I have an index of 2, so I want groups of 2. So this doesn't have a group of 2, so it's going to stay underneath. And then I have 1, 2 2's that are going to come out in front. So I have a 2 and a 2. They're going to come out in front and multiply to that 5. And then we're going to take this index of 2 and divide it into the 9. So just like we divided before, 9 divided by 2, right? 2 goes in there 4 times. 2 times 4 is 8, with 1 remaining. So what does that mean? That means, let's go ahead and finish the numbers out in front. So 2 times 2 is 4. 4 times 5 is 20. Okay? So this right here, 9 divided by 2, well, 2 went into 9 4 times. So 4 x's, so 4 of my bases are going to come out in front. So I have x to the 4th that comes out in front. And then my remainder, I have the 3 that was remaining underneath there, and then I had a remainder 1 here with my x. So I have an x here. And then that is it. And we probably should start to talk about absolute values as we did yesterday. So I've kind of not mentioned them because I was focusing more on the adding and subtracting. But remember, if you have an even index, it's understood that you're taking a positive root. So if you have a variable that comes out in front and its exponent is odd, you need to put in absolute value signs. It doesn't matter underneath. Just worry about what is out in front. So because this is even, we'll leave it alone. All right, so you try number 12 and then check your work with me. All right, so I don't have any coefficients out in front. And so I've got the cube root of 54 is 9 times 6. And so 9 and 6, so 54 is 9 times 6. And so 6 is broken up into a 2 and a 3. Okay, so the 9 is 2 3s. So I actually end up with 3 to the 3rd and then times a 2. And then times the 5. So the 54 here is 27 times 2 is 54. And then this is the 5. And then m to the 8th times m to the 4th. Add those exponents. You get m to the 12th. Then all you have to do is take your index and divide it. I can divide that one. I cannot divide the indexes or the exponents of 1, but I can divide this one. And so these ones happen to go in evenly. And so this is going to come out as this one right here is going to come out as a 3 out in front. This one here, 12 divided by 3 is 4, so it's going to come out as m to the 4th. And then you're going to have what's left over, cube root. This 2 times 5 is 10. And so that should be it. So let's see, this is our final answer. Now, it's an odd index, so I don't really care about anything out in front, and that's even anyway. Okay, so then you can try these on your own. I'm going to quickly write out the answers, so pause the video, try them if you want to. If you feel like you've got it, then don't. But I'm going to go ahead and go through the answers. So for this one, I've got the cube root, and I have negative 3 times 36. I'm going to pull that negative out as a negative 1 times, and then a 36 is 6 times 6, and each of those 6's have a 3. So I've got 2 3's in the 36, and I have a 3 here. So I have 3 to the 3rd times, and then the 2 6's each have a 2, so then I have 2 squared. And then a to the 7th, a to the 6th, add those exponents, I get a to the 13th. And then b to the 4th, b to the 2nd, add those exponents, I get b to the 6th. Make sure you're adding and not multiplying. And then I'm going to take the index here and divide it on any one of the exponents that could be divided by 3. So because 2 squared is not divisible by 3, the 2 is not divisible by 3, I'm not going to try it. And of course this negative 1 comes out as a negative 1. So that comes out as a negative 1. And then 3 divided by 3 is 1. So this one right here is going to come out as a single 3, nothing left over. And then this one is going to stay under the radical. And then this one right here, it's going to come out with a remainder. Reason being, 13 divided by 3. 3 goes into 13 4 times. 3 times 4 is 12, with 1 remaining. So I have a 3 to the 4th, or I'm sorry, an a to the 4th. The base is a to the 4th, because 3 went in there 4 times. And I'm going to have 1a remaining, so that's how this one came out. And then finally, our b to the third, this one right here, b to the sixth divided by 3 is going to be b to the second, because 6 divided by 3 is 2. And the only thing left underneath this right here is going to be 2 squared. We didn't do anything with that. Remember, we had a remainder with the a, and we only had 1 remaining. So to multiply it all together, we get -3 a to the fourth b squared cube root of 2 squared is 4a. And then this is your final answer. Okay? And then finally number 14. So with 14, I'm going to multiply coefficient to coefficient. So 2 times 7 is going to be 14. We have the same index, so I can combine what's underneath. And so p to the second, p to the third, add those exponents, you get p to the fifth. Q to the first, q to the 10th, add those exponents, and you get q to the 11th. So then here's your index. Divide it through. So 4, we're going to divide by 4. Okay? So off to the side, for those of you who still have trouble seeing it, 4 goes into 5 once. 4 times 1 is 4, with 1 remaining. So I'm going to have a 14 out in front. And then that means that because 4 goes into 5 once, I'm going to have 1p out in front and 1p remaining underneath this 4th root. Okay? And then with the q, 11 divided by 4, 4 goes into 11 twice. 4 times 2 is 8. So this one is interesting because I actually have a remainder of 3. So what's going to happen is, because 4 went into 11 twice, I'm going to have 2 q's out in front, so q squared, but I'm going to have 3 q's remaining underneath because that's my remaining. And if you stretch out 11 q's and circle your groups of 4, you'll see that you have 2 groups of 4, which is why you have 2 q's, and you'll have 3 left over. And so this ends up being the final answer. Now, let's talk about squaring or multiplying binomials, or in this particular case, number 15 is a monomial to a binomial. So the same mantra applies. You're going to multiply, when you distribute this all the way through, you're going to multiply coefficient to coefficient, radicand to radicand. So when I multiply here, my coefficient is a 1 here. So I'm going to multiply 1 times 5. So when I multiply these two here, I get a 5 square root, and then I have 10 times 5. Well, usually I don't multiply 10 times 5 is 50. I just stretch them out. 10 is 2 times 5, and then times the other 5. So I don't actually multiply them, okay? I just stretch them out. So here's your 10, and here's your 5. And then for your next multiplication, so from here to here, I have 1 times -2, which is -2, square root of, and then my 10 again is 2 times 5. And I'm multiplying this 10 to that 2, so I have another, I'm going to erase that 5 and move it over because I want to put the other 2 right next to it. And there we go. All right, so then I want to simplify. So I have a group of 5s that come out in front here and multiply to here. So that's going to give me 25 with my remaining 2 underneath. And then I'm going to have this group of 2's come out in front, and it's going to be multiplied to the 2. And so I end up with -4 square root of 5. And that is as far as I can go because I do not have like radicals. I have like indexes, but the radicands are different, so I cannot combine those. That's as far as I go. So let's look at a binomial times a binomial. So you're going to FOIL. You're going to do first, and then you're going to do outer, and then you're going to do inner, and then you're going to do last. Okay, so for my first, I'm going to multiply the 8 to the 3, which is 24. And then for my outer, that's the outer two terms, I'm going to multiply the 8 to, there's a 1 in front of here. So I've got the 8 times the 1, and we're just going to tack on radical 10, just as if we're multiplying 8 times negative x. Wouldn't it be negative 8x? So 8 times negative radical 10 is negative 8 radical 10. So minus 8 radical 10. And then for my inner, we're going to distribute the negative 10 into everything. So negative 10 times 3. So negative 1 times 3 is negative 3. And then I don't have a radical to multiply this 10 to, so we just tack it on. So radical 10. And then finally, my last, I'm going to multiply radical 10 times radical 10. Well, I have a negative times a negative, which makes a positive. And then remember, anytime you multiply a radical times itself, you get the number under the radical, and here's why. If I take radical 10 times radical 10, that means that 10 times 10 would go underneath. And 10 times 10 is 100, and the square root of 100 is 10. So anytime you have a radical times itself, you're going to get just the number underneath the radical. And that only happens with square roots, so be careful. So then we get a 10. So then we want to identify like radicals. Doesn't the negative 8 rad 10 and the negative 3 rad 10 have the same radical? Index and radicands are the same. So that means I can combine them as like radicals by adding their coefficients. And in addition to that, these two are both constants. So I can combine my constants. So the 24 and the 10 becomes 34. Negative 8 and negative 3 becomes negative 11 radical 10s. And this is my final answer. I cannot go any further. Do not try to take 34 minus 11 and say that it's 23 rad 10. You cannot combine these two. This 11 has a radical 10 attached to it. You cannot go any further. Okay, so what I want you to do is try 17 on your own. You're going to do the same thing I just did on 16. You're going to multiply and you're going to FOIL. So you're going to take this 6 rad 6 and multiply it to here and multiply it to here. So that's first and outer. And you're going to take the negative 6 rad 2 and multiply it to here and multiply it to here. That's your inner and last. So pause the video and try your FOIL and then restart the video. So F O I and then L. Okay, so here we go. So first, I have 6 times a 1, so that gives me a 6. And then this one's interesting because you have radical 6 times radical 6. That's radical 36, which is equal to 6. Remember, radical times itself is the number underneath the radical. So we multiply that by 6. So it will end up being a 36 when all is said and done. But let's look at our outer. All right, so our outer is going to go to here. So I have a 6 times a 1, which is a 6, and that's positive. And then I have a radical 6 times a radical 2. So a 6 has a 2 and a 3 in it, so I choose to stretch those out. So 2, and then I'm going to bring the 2 in, and then the 3. So what did I just do? 6 is 2 times 3, and here's the 2 from that one. And I did that so I could simplify that radical in a minute. All right, so then my inner right here. So again, I've got a negative 6 times a 1, so that's going to give me a negative 6 out in front. And then same thing as I did before, 2 times 6, that 6 is going to get broken into a 2 and a 3 and a 2. So I have a 2 times my 6, which is 2 and a 3. We'll simplify that in a minute. And then finally last, multiply these together. I've got negative 6 times 1, which is negative 6. And then I have a radical 2 times a radical 2. A radical times itself gives you the number under the radical, so that's times 2. So back over here to the beginning, 6 times 6 is 36. And then here I can take a pair of 2's out in front and multiply it to the 6. So I get positive 12, radical 3. I can take a pair of 2's out here and multiply it to the 6. So I get a minus 12, radical 3. And then here, I get negative 6 times 2, which is negative 12. Okay, so then we have one final set of like terms to go. And so notice that these are constants, so I can combine those. 36 minus 12 is 14. And then you'll also notice that these two here are opposite signs. I've got positive 12 rad 3's and negative 12 rad 3's. So they cancel out and we will just be left with 14. All right, so what do you do with a squared binomial? So remember, you all struggle with this because you try to square this and say it's 16 and square this, rad 5 times rad 5 is 5. So you try to tell me it's 16 minus 5, which is 11, and that's not true. Remember that a squared binomial means that you're going to take 4 minus the square root of 5 and multiply it to itself, 4 minus the square root of 5. So at this point, I want you to FOIL. Pause the video, and I want you to FOIL and tell me that you don't get 11. You should have a middle term. So pause the video, FOIL. So I've got F-O-I and L. Okay, so first, 4 times 4 is 16, and then outer. 4 times a negative 1 is a negative 4, and then you tack on that rad 5. And then inner, 4 times a negative 1 is a negative 4, and you tack on that rad 5. Notice how these do not have opposite signs. They don't cancel out. And then finally for our last, we're going to have a negative times a negative, which is a positive, and rad 5 times rad 5, its times itself, is just the number under the radical, which is 5. So we get to combine our constants. 16 and a positive 5 is going to give you 21. And then a negative 4 rad 5 and a negative 4 rad 5. That means you add the coefficients. So negative 4 plus negative 4 gives you negative 8 radical 5. So it did not turn out to be 11. All right, we're almost there. So then I want you to try these two on your own. So pause the video, see if you can do them, and then turn the video back on. So remember, coefficient to coefficient, radicand to radicand. All right, so for this first one, I'm going to multiply these two together. And I don't have anything in front but a 1. So the 3 is prime. I'm going to tear the 12 apart into a 3 that'll combine with that 3, and then a 4, which is 2 2's. So I get the square root of, there's the 2 2's from the 12, and there's the 3 from the 12. And then this is the 3 from the 3. And then I have k times k. So I'm just going to actually stretch that out since I stretched out the others, but you could write it as k squared. And then I've got this times this. So my coefficient is 1 times a negative 2. So I have a negative 2 square root. And then I have the 3. So I'm going to write that 3 down. And then times the 15. So the 15 is 3 times 5. And then I have a k and a k squared. So you could leave that as, we'll do that one as k cubed, so we'll get used to doing the power rule as well. Okay, so then let's go ahead and figure out what we're going to pull out in front. So I'm going to have a 2 out in front from there, and then this is a group of 2, so then I have a 3, and this is a group of 2, so I have a k. So that's a perfect square. So 2 times 3 times k is going to give me 6k. So that first one becomes 6k. And then for the next one, I can pull out a pair of 3s. So that's going to come out in front right here, multiply the 2. The 5 is going to stay underneath because it doesn't have a pair. And then remember the index here is 2, so I'm going to divide that 3 by 2. We'll deal with that in a minute. So 3 times 2 is 6, so I have a minus 6. And then I have a, well, I'm going to leave a little space, and I have a square root, which I want to be in black, square root. And then I have a 5 that got left underneath, right? So remember here for the k, 2 goes into 3 once, so 1k comes out in front. Because 2 goes into 3 once, that's a 2. It leaves you with 1k left over. So that's going to stay underneath. Now it looks like, yeah, 6k minus 6k should be 0, but it's not. Remember, this 6k has a radical 5k attached to it. They are not like radicals. You cannot combine them. So this is your final answer. All right, finally number 20. So let's zip through this one. We're going to FOIL it. So radical x times radical x, the radicands are the same. So you're taking a radical times itself, you get what's underneath the radical. And then radical x times radical 2, there are no coefficients, so it's a plus. And then square root x times 2 should be written as 2x, not x2. Then I'm going to take the negative rad 8 times the x, so I get negative square root, and I'm going to take the rad 8 and stretch it out as 3 2's, and then an x. And then negative times a positive is another negative. And then the 8 is 3 2's, and then the 2 is another 2. So the x stays an x. I cannot simplify the square root of 2x, so that stays the square root of 2x. But I can take out this pair of 2's out in front, so I get minus 2. This stays underneath, square root of 2x. Then here I can take out a pair of 2's, so that's going to be 2 times 2, so that's a minus 4. All right, so almost there. Remember, there's a 1 in front of here, so aren't these like radicals? They both have a radical 2x. So I can combine them by using their coefficients. So 1 minus 2 is a minus 1. So minus 1, and it's radical 2x. And then I'm going to put, these are left, right? So I'm going to put the x out in front and then the minus 4. I'm just going to write it that way. You can put them in whatever order you want to, as long as the sign goes with the term. But none of these are like terms, so that's going to be your final answer. And then our last problem is to find the area and the perimeter of the rectangle shown to the left. All right, so for your area, remember that area of a rectangle is length times width. So the area of this rectangle is going to be, and I can't see all of them because I have some stuff in the way, so it's 7 rad 6, that's a 7, rad 6 plus radical 3, and then that's times 4 minus the square root of 6. Okay, so I'm going to leave you, whoops, I just hit my lamp. I'm going to leave you to multiply that out. And then for the perimeter, remember the perimeter is twice the width plus twice the length. So our perimeter is going to equal twice the width. Well, the width is 4 minus the square root of 6 plus, I'm going to squeeze this in here, twice the length, which is 7 radical 6 plus radical 3. Okay, so you do that work, pause the video, and then restart it and check your answers. Okay, so right here I have 7 times 4, because remember we're going to do coefficient to coefficient, so 7 times 4 is 28. And then I don't have a radical to multiply to the 6, so 7 times 4 became the 28, and then you tack on the radical 6. All right, next one, we're going to multiply to here, we're foiling. So I've got 7 times a negative 1, which is a negative 7. And then we have a radical 6 times a radical 6. A radical times itself is just the number under the radical, so it becomes negative 7 times 6. And then we're going to distribute the radical 3. So radical 3 times 4, we've got a 1 times 4, which is where we're going to get a plus 4. And then we don't have anything to multiply the radical to, so you just tack on radical 3. All right, and then we're going to multiply the radical 3 to the 6. We have a positive times a negative, which makes a negative. And then everything's under the radical, so I'm going to stretch it out. So I have a 3 times, so there's my 3. And then my 6 is 3 times 2. So let's finish it up. So the first term, 28 rad 6, we cannot do anything with, so it stays 28 radical 6. And then negative 7 times 6 is negative 42. And I cannot do anything with the plus 4 square root of 3. But we can take out a pair of 3's out in front here, and so we get minus 3 square root of 2, because the 2 is left over. And if you look at what's left, none of these are like radicals, none are like terms. So this is an uncomfortable answer, but this is our full answer for area, and that's in units squared. And then let's look at perimeter. So for perimeter, I'm going to multiply the 2 through, so I get 2 times 4 is 8. And then I have 2 times radical 6, a negative radical 6, so it's a minus 2 radical 6. And then I have a 2 times 7 radical 6, so 2 times 7 is positive 14 radical 6. And then a 2 times a radical 3, which leaves us with a positive 2 radical 3. All right, so we actually do have like terms here. So both of these have a radical 6, so I can add their coefficients. So then I'm going to have an 8, and then a minus 2 and a positive 14 gives me a positive 12 radical 6, and then plus 2 radical 3. None of those are like terms, so this is my perimeter, and that's in just plain units. All right, so that was a lot. If you have any questions, feel free to ask.